Mars, the enigmatic red planet, has captivated humanity's imagination for centuries. Its barren landscapes and potential for harboring past life make it a prime target for exploration. However, Mars holds another celestial wonder: its two small moons, Phobos and Deimos. These celestial companions, named after the Greek gods of fear and panic respectively, offer a glimpse into the dynamic processes shaping our solar system. Phobos, the larger of the two, is a cosmic oddity. Its irregular, potato-like shape and heavily cratered surface hint at a violent past. Deimos, on the other hand, is much smaller and smoother, resembling a large asteroid. Their contrasting appearances raise intriguing questions about their origins and their relationship to Mars. While both moons hold scientific value, Phobos stands out as a celestial object on borrowed time. Its fate is inextricably linked to the gravitational forces governing the Martian system, leading to a future that promises to be both dramatic and scientifically enlightening. Understanding Phobos' destiny provides valuable insights into the intricate dance of gravity, tidal forces, and the evolution of planetary systems. Phobos circles Mars at an astonishingly close distance, completing an orbit in just under 8 hours. This rapid orbital pace, significantly faster than Mars's own rotation, sets Phobos apart from most other moons in our solar system. While our moon steadily retreats from Earth, Phobos is spiraling inward toward Mars at a rate of about 6 feet per century. This inexorable inward drift is driven by the relentless tug of gravity. The gravitational interaction between Mars and Phobos creates tidal forces, similar to those responsible for Earth's tides. However, the effects on Phobos are far more dramatic due to its proximity to Mars and its weaker gravitational hold. As Phobos draws nearer to Mars, these tidal forces intensify, gradually stretching and distorting the moon's structure. This gravitational tug-of-war will ultimately determine Phobos' fate, leading to a spectacular celestial event that will forever alter the Martian landscape. Tidal forces arise from the difference in gravitational pull exerted by a celestial body on different parts of another body. In the case of Phobos and Mars, the side of Phobos facing Mars experiences a stronger gravitational attraction than the side facing away. This difference in gravitational force creates a stretching effect, elongating Phobos along an axis pointing toward and away from Mars. These tidal forces are not static but rather vary in intensity as Phobos orbits Mars. As the moon approaches its closest point to Mars, the gravitational gradient steepens, intensifying the tidal forces. Conversely, as Phobos moves further away, the gradient decreases, and the tidal forces weaken. This cyclical stretching and squeezing repeated over countless orbits takes a toll on Phobos' internal structure. The moon's rocky composition, lacking the cohesive strength of larger celestial bodies, is gradually weakened by these relentless tidal forces. The Roche limit, where moons meet their doom. The ultimate fate of Phobos is dictated by a critical threshold known as the Roche limit. This theoretical boundary, named after the French astronomer Édouard Roche, marks the distance from a celestial body within which tidal forces overcome the gravitational forces holding a satellite together. When a moon ventures within its planet's Roche limit, the tidal forces become so overwhelming that they rip the moon apart. The fragmented debris, no longer bound by gravity, then disperses along the moon's orbital path, forming a ring system around the planet. Phobos' inward spiral brings it perilously close to this celestial Rubicon. Current estimates suggest that Phobos will cross Mars's Roche limit in tens of millions of years, marking the beginning of its demise. This dramatic event will transform Phobos from a solitary moon into a dazzling ring system, adding a new chapter to the red planet's celestial story. A Martian ring in the making? As Phobos succumbs to the relentless pull of tidal forces, its fragmented remains will spread out along its orbital path, creating a ring system around Mars. This ring, composed of countless particles of rock and dust, will reflect sunlight, potentially creating a spectacular celestial display visible from Earth. The formation of a Martian ring from Phobos' debris would be a relatively short-lived phenomenon, at least in astronomical terms. Over millions of years, collisions between ring particles and atmospheric drag would cause the ring to gradually lose altitude and spiral inward toward Mars. Despite its ephemeral nature, the existence of a Martian ring, even for a few million years, could have significant implications for our understanding of the red planet's past. The composition and distribution of ring particles could provide valuable clues about Phobos' internal structure and the processes that led to its formation. Unraveling the origins of Phobos and Deimos. The origins of Phobos and Deimos have long puzzled astronomers. Their small size, irregular shapes, and composition resembling carbonaceous asteroids have led to various hypotheses about their formation. One prevailing theory suggests that they are captured asteroids, snared by Mars's gravity during the early solar system's chaotic history. Recent studies, however, have proposed an alternative explanation. These studies suggest that Phobos and Deimos may be remnants of a larger Martian moon that was shattered by a massive impact. This impact hypothesis could explain the moon's compositional similarities to Martian meteorites found on Earth. Further observations and missions to Mars's moons are crucial to unraveling their enigmatic origins. By studying their composition, surface features, and orbital dynamics, scientists hope to gain a deeper understanding of the processes that shape these celestial companions and their implications for the evolution of the Martian system. Planetary rings, echoes of a tumultuous past. The potential formation of a ring system around Mars from the remnants of Phobos highlights the transient nature of celestial objects. Planetary rings, once thought to be rare occurrences, are now recognized as relatively common features in our solar system. The gas giants, Jupiter, Saturn, Uranus, and Neptune, all possess elaborate ring systems, while even smaller bodies like the asteroid Chariklo and the dwarf planet Haumea have been found to harbor rings. These ring systems serve as cosmic breadcrumbs, offering clues about the violent and dynamic history of our solar system. They are often the result of collisions, disruptions, and gravitational interactions that have shaped planetary systems over billions of years. Some scientists even speculate that Earth may have possessed a ring system in the distant past, perhaps formed from debris ejected during the moon-forming impact. Studying planetary rings provides valuable insights into the processes of accretion, collisional evolution, and the long-term stability of planetary systems. By unraveling the mysteries of these celestial rings, we gain a deeper appreciation for the dynamic and ever-changing nature of our cosmic neighborhood.